This video will show you the application of the Pythagoras theorem. Now we can see this question and with the graph here. So we need to read the question first and label all the information on the graph. So we can see if we have got a 2.6 meter ladder, so that AB is the ladder, so that is 2.6 meters. And then that is leaning on the vertical wall AO. So in position 1, AO is 2.4, so we can label that AO is 2.4 meters. And then if the ladder is sliding down 0.5 meters from A to C, which means this part is 0.5 meters. It's the bottom of the ladder moving 0.5 from B to D as well. So that means the BD is BD 0.5. So we need to calculate the length of BD. Now, considering the two positions, we want to draw them separately. So let's have a look at the first position. So we draw that first position. Position 1. So for the first position, this is a right angle triangle. So AO and B. So that is the original, like the place of the ladder. So we draw that. Right angle triangle. So we label A, O, and B. And angle O is a right angle. Okay, so AB is 2.6, AO is 2.4, and we need to work out OB because we want to know BD, so we need to know OB first. Okay, according to the Pythagoras theorem, we've got AB squared, the longest squared equals OA squared plus the OB squared, the shortest square. Alright, so we substitute. So AB is 2.6 squared equals OA is 2.4 squared, and then we can write OB squared like that. And then we do the further calculation. So OB squared equals 2.6 squared, take away 2.4 squared. Use your calculator, and that equals to 1. Which means OB equals square root 1, so we don't have to think about the negative situation because that is the length, and then equals 1 meters. Alright, so OB is 1. And then we think about the second situation, the second position when the ladder was sliding down a little bit. Alright, so we need to draw position 2. Alright, for position 2, this is still a right angle triangle. So we still draw that right angle triangle. You don't have to draw that to scale. Alright, and then we label that. So for this right angle triangle, we have C, O, and D. So we label that C, O, and D, and then with a right angle here. Alright, so we label that as well. So we'll put all the information on this graph. So CD is still that ladder, alright, although it's sliding down, so that is still 2.6 meters. OC, so OC is not 2.4 because this ladder sliding down 0.5 meters from A to C. So the length is 2.4 take away 0.5, which is 1.9. And then we need to find OD. The purpose of doing that is if we know the length of OD, and then we take away OB, and then we can find BD. Alright, so we still use the Pythagoras theorem, which is the longest side square, so CD squared equals OC squared, shorter squared, plus the shorter square, OD squared. And then CD squared is 2.6 squared equals OC squared 1.9 squared plus OD squared. So OD squared is 2.6 squared, take away 1.9 squared, and then that is 3.15. Calculate that using your calculator. And then OD is square root 3.15, so we don't have to think about the negative situation. Alright, so that's approximately equal to 1.77 meters. Alright, so the approximate equal sign is very important because that is an irrational number. Now, we know the length of OD, so if we take away OB, so we can have BD. So BD equals OD, take away OB, which is 1.77, take away 1, equals 0.77 meters. Now, from this calculation, we can see that actually the horizontal movement from B to D is not 0.5. That should be 0.77. Okay, now let's answer this question. The bottom of the ladder was moving 0.77 meters rather than 0.5 meters.